fell. Have you ever seen the Northern Lights or the Southern Lights? I've been lucky enough to see them once, and it was truly amazing. These beautiful bands of light stretching across the night sky are called auroras, but what causes them? If you thought it might have something to do with the aurora in your car, well, you're not that far off. The Aurora Borealis or Northern Lights occur when charged particles from the sun get carried along Earth's magnetic field lines and precipitate into the upper atmosphere, where they cause the gas molecules to glow. So how exactly does this happen? Well, let's start with the beginning. The sun emits a constant stream of charged particles called the solar wind. This is a bit of an oversimplification, but these particles are mostly made up of protons and electrons. As these particles travel through space, they can interact with magnetic fields. Net interaction depends on both the strength of the magnetic field and the speed of the particles. Now we know that Earth has a magnetic field, which is generated by the dynamo effect in our planet's core. This magnetic field extends from Earth's surface all the way out into space, forming a protective bubble around our planet, known as the magnetosphere. The magnetosphere is constantly being bombarded by the solar wind. And while some particles can get in, most are kept out. Earth's magnetic field is strongest at the poles, and the solar wind is able to funnel some of its particles down along the field lines near the poles. When these charged particles reach the upper atmosphere, they collide with neutral atoms, typically oxygen or nitrogen. The charged particles can transfer some of their energy to the neutral atoms, causing them to be left in an excited state. An excited state is when an atom has absorbed energy and is in a higher energy level than normal. Eventually, these excited atoms will return to their normal state and release the extra energy as light. This process is known as fluorescence. The color of the light emitted depends on the type of atom and the altitude of the collision. For example, if the collision occurs at high altitudes, where there are mostly oxygen atoms, the auroras tend to appear green. At lower altitudes, where there are more nitrogen molecules, the auroras tend to be red. The strength of the solar wind can vary greatly. It's stronger when the sun is more active and when Earth passes through regions of charged particles known as coronal mass ejections or CMEs. CMEs are large, bright plasma features that extend outward from the sun during a solar flare. They often erupt from sunspots and carry with them a significant amount of magnetic field. As the CME approaches Earth, it interacts with our planet's magnetosphere. If the CME is strong enough, it can actually compress the magnetosphere, pushing the Van Allen radiation belts closer to Earth. This can result in an intense geomagnetic storm. Geomagnetic storms can disrupt important things like our telecommunications and our power grid system. While it's nice to look at these beautiful auroras, sometimes they can be a little too beautiful. In 1921, the Northern Lights were so intense that they interfered with radio communications between ships at sea. And in 1989, a geomagnetic storm caused by Acme destroyed the power grid in Quebec, Canada, leaving 6 million people without electricity for 9 hours. Let's go back to the Aurora Borealis. The best place to see them is at high latitudes, such as in places like northern Norway, Alaska, and northern Canada. In fact, the name Aurora Borealis comes from the Roman goddess of the dawn Aurora, and the Greek word bios, which means light. The Southern Lights, also known as the Aurora Australis, appear at high southern latitudes. The best places to see them are in places like New Zealand, Tasmania, and the southern tip of South America. The Aurora Australis is actually seen more often than the Aurora Borealis. That's because Earth's magnetic field is a bit wonky near the South Pole. It's much easier for charged particles to reach the Southern Lights than the Northern Lights. You can even see the Aurora Australis from some parts of Antarctica. While seeing the Northern Lights is amazing, it's also pretty cold. You can find the aurora in the winter in places like Finland, Sweden, and Norway. The Northern Lights are most visible during the months of September, October, November, February, and March. During these months, the nights are long and dark, making it easier to see the faint glow of the auroras. Plus, the air is usually very cold and clear, which means there's less atmospheric interference. There are a number of places that you can visit to see the Northern Lights. One of the most popular spots is Fairbanks, Alaska. Fairbanks is located within the auroral oval, the region where the auroras are most commonly seen. Another great place to see the northern lights is Tromsø, Norway. This city is located just south of the Arctic Circle and offers stunning views of the northern lights. Other popular destinations include Reykjavik, Iceland, Rovaniemi, Finland, and Abisko, Sweden. The best time to see the northern lights is during solar maximum. This is when the sun is most active and the solar wind is strongest. The next solar maximum is predicted to occur in 2025. So if you want to see the northern lights at their best, then that's when you should plan your trip. And finally, you need a clear view of the night sky. This means avoiding places with a lot of light pollution. Light pollution can make it difficult to see the faint glow of the auroras. So it's best to head to a remote area with minimal light pollution. Seeing the northern lights is truly a once-in-a-lifetime experience. The best place to see them is at high latitudes in the winter. The best time to see them is during solar maximum. And the best way to see them is away from city lights. Aurorae aren't only found on Earth. Many moons in the solar system also have aurorae, including Jupiter's moon Europa, Saturn's moon Enceladus, Neptune's moon Triton, and possibly even Mars. Aurorae on other worlds are similar to the ones we see on Earth, but they can also be very different. For example, Europa's aurora is thought to be generated by magnetic fields that are created by the Moon's subsurface ocean. Enceladus's aurora, on the other hand, may be generated by the Moon's active volcanoes. We can learn a lot about the moons in our solar system by studying their aurora. For example, by studying Enceladus's aurora, scientists have learned that the Moon has a subsurface ocean of liquid water. And by studying Europa's aurora, scientists have learned that the Moon has a magnetic field. And here on Earth, auroras can tell us a lot about space weather. For example, the intensity of auroras can be used to measure the strength of the solar wind. By measuring the strength of the solar wind, we can predict things like geomagnetic storms. So the next time you see a beautiful aurora, remember that it's not just a pretty light show. It's a window into the dynamic processes that are constantly occurring in our universe. Thank you for watching this episode. If you liked it, please hit the like button below. All the references used are added in the description below. And if you haven't subscribed yet, what are you waiting for? There's more videos coming soon.